Hello everyone, and welcome on this video. My name is Anthony, but for this project I will answer to the nickname justumen. I'm a computer lover, an open source and free software enthusiast, a teacher at heart, and a self-proclaimed computer hacker. As you can see from the public domain image behind me and the high definition camera, this video has a very high production value. But despite my current surrounding, I'm not here to talk about religious philosophy. Instead, I'm here to talk about one of my current projects. I wish to create a series of video lectures about computers. I will describe and explain their influence and their potential. So, binary is incredibly cheesy here, but at least it's on topic. My lectures aim to be pragmatic, dynamic, and as entertaining as possible. Most of them are going to focus on computer technical knowledge and are designed for enthusiastic students. But I will also have a place for non-technical lectures for all the average computer users. My lectures and all related projects are going to be free and without advertising, at the image of Wikipedia, relying only on donations. My goal is not to make it a business, but to work on it full-time and produce high-quality content. I hate ads, and I always will. I don't want them in my life, and I don't want them in yours. Also, as a non-elitist, I don't want money or even the lack of computer knowledge to be an obstacle for people who are really interested in computer technology. Some concepts and ideas related to computers are today just incredibly important, and some of them are probably going to shape the future of mankind. The video you're watching right now is non-technical, and therefore, to paraphrase myself, you don't need any computer knowledge to understand it. In this video, we are going to see several computer programs in action, but we won't talk about the computer code itself. So if you are interested in knowing how things actually work, you will have to refer to the corresponding lecture, where I will take the time to talk about all the details. So in this video, we are just going to scratch the surface of some of the subjects from this list. I will add more subjects to this later, but these are my main priorities. And today my goal is just to give you an overall idea of what I will talk about in my lectures. So for every subject in this list, I will make at least one special non-technical lecture about it. In there, I will try to give you as much information as I can with no prerequisites in computing. I will do the same for other important concepts that are not listed here, like open source, hacktivism, free software, malwares, cyber terrorism, peer-to-peer networks, cryptocurrencies, piracy, and so on. So, besides the lectures, you will have access to different websites where you can learn, comment, chat, criticize, ask questions, and so on. This is an example of one of the websites where you can have access to all the lectures and details about them, like quiz, exercises, code you can copy paste, and so on. The website will also give you experience and levels, exactly like a video game would, to really give you a feedback on your progress. I will talk about storylines later in this video, but let me give you an example first. Let's say you join the website and you choose the How to Be a Computer Hacker storyline. Everyone will see that you are, for example, a computer hacker level 22. It will make it easier for me or other people to give you an appropriate answer based on your current level. So, most of the subjects from this list are software related, with few exceptions. In this section, components, for example, we'll talk about the structure that all computers have in common, including smartphones, tablets, servers, and mainframes. Don't be tricked by their names, all of them are indeed computers. I will talk about simple stuff like CPU, RAM, storage, and explain how they all work together to make the magic of computing happen. I will focus on the minimum knowledge you need to have to understand your computer better, understand your operating system better, and improve your overall programming skills. Together, we'll try to improve the global performances of your machines by understanding them better and customizing our environment to our needs. In there, I will not talk about computer products or benchmark the latest graphic card or CPU. I just don't care about that. I'm also not interested in gadgets, so I won't talk about them either. As far as hardware is concerned, I might talk about some devices or uncommon peripherals, but only when they have, in my opinion, a real innovative oriented, software oriented purpose. Things with at least some degree of revolutionary potential, like augmented reality headsets, virtual reality headsets, quantum computers, or three-dimensional printers. And of course, we'll see what kind of programs we can make with these devices in mind. Aside from teaching, I will often give you my personal opinion about the current subject. But every time I do, you will be warned about my deliberate lack of objectivity, with the appearance of a primate on the screen. And you will have the option to avoid them altogether, if you so desire. If you are only interested in raw computer knowledge, for example, you are free to skip them. So most subjects in this list have self-explanatory titles. So I'm not going to go over them one by one, but I'm instead going to talk about those who aren't obvious. Let's first talk about two obscure titles that kind of goes together: social revolution and brain hacking. But before talking about them, I want to be transparent about what I will do in this project. I will sometimes talk about shady things, like exposing some computer criminal tactics and some degree of manipulation. It is just a fraction of what my project is about, but we can't avoid these subjects in the interest of full disclosure. Knowing about some of it can significantly help you protect yourself and people close to you. But for me, it's always tricky to talk about that, and I don't want my intentions to be misinterpreted. All of what I'm going to talk about in security is aimed at protecting the user. But as we are going to see together, fancy tools will not be able to protect you on their own. When it comes to personal protection, nothing can replace knowledge. So that being said, in Social Revolution, we'll try to understand the ongoing influence of computers on a global scale and talk about the effects of modern technology in our lives. So we'll talk about some recent world events like political instability, public division, elections or civil wars, and we'll try to understand the roles of computers within them. For one example, we'll take a look at the structure of some social media platforms, and we'll try to measure their responsibility in these events. We'll see if social media just give everyone the ability to communicate or if there is more to it. On a lighter note, we'll talk about how computer engineers were able to transform our culture by designing almost exclusively addictive systems and products. As an example, in just a few years, social media were able to change our definition of private life altogether. Most people now apparently want to share absolutely everything they do, however personal it might be. As of now, the universal definition of private life seems to be reduced to what is happening in the bathroom. But this is a recorded video, so from my point of view, you are living in the future. So maybe for you, colors and shapes are already trending subjects. I don't know. So we'll try to understand how much of this sharing frenzy is a real wish and how much of it was engineered for the sake of advertising. Of course, we'll talk about online propaganda, from special interests to governments. We'll first talk about the basics of propaganda and see how it was used in history. After that, we'll try to understand the big differences between the classical way of spreading information and what computers and the internet brought to the mix. We'll analyze the paradox that is why the information age, instead of protecting us from propaganda, just appeared to make us more vulnerable to it. And in the section brain hacking, we are going to talk about manipulation techniques and what you should know to avoid being a victim of it. We'll see in there how protected we are from conditioning and other form of brainwashing. There is currently no anti-malware for our brains, so the only option for us is to learn about some key concept to avoid being an easy target. In there, I'll try to describe and explain how malicious entities, individuals, organizations, or governments can use computers and computer-related technologies to control other people's beliefs, opinions, and even actions. My goal is to show you that brain hacking isn't science fiction, but is already happening online. As a demonstration, we'll see how a customized digital environment around someone can in time replace some of its individuality with predictable stereotypes. For example, by creating a large quantity of bogus social media accounts, it is possible to use an artificial social leverage to change someone's opinion. It is possible to give people the illusion of being part of a group and reward them if they behave in a specific way. It's like the positive reinforcement that is used on pets. You just give a treat every time you want the recent behavior to be repeated. In my example, the treats are just replaced by likes, share, comments, or similar rewarding features, all depending on the targeted platform. We can use these to encourage a specific type of content by making it popular. It might be counterintuitive for some people, including me, but it seems that a lot of people consider that popular and good are somewhat synonyms. In the case of an authoritarian regime, for example, sharing a picture of our dear leader on social media can be heavily rewarded with a barrage of fake likes and patriotic comments. Or it can be simply used against soft targets, like a child or an inexperienced internet user, like I said, to manipulate his opinion about a specific subject. If this method is successful, these people are considered assimilated and can move on spreading the same propaganda on their own. After that, their free will is just part of this very dangerous system. It is used most of the time for political purposes, are often based on sectarianism or spread hatred toward a specific group or an individual. You shouldn't be paranoid, but online there is a constant war of opinions where a lot of actors just aren't people. So you simply need to understand that not all social media accounts are real. I was wondering what I can show you here because I'm not a journalist and I don't want to point fingers. And I also don't want people to think that I'm taking sides because I'm talking about one and not the other. Hopefully for me there is a comedian called Joe Manday. He has around 1 million followers on Twitter, but bought most of them. And he's very open about it. These fake accounts are just here for boosting his popularity, but there are still several armies ready to be hired for less innocent purposes. So this is my infamous Twitter account with the impressive amount of 0 tweets and 0 follower. I personally don't have a million automated Twitter accounts for this demonstration, but I've programmed a few as a proof of concept, and I can show you with 5, hopefully without getting into trouble. So as soon as the order is received, 5 automated accounts are going to follow me on Twitter. So let's wait a moment. All right. So now let's refresh the page and see what's happening. All right. So now you can see, you can clearly see that. I hope you understand clearly that an account doesn't always represent a person, and that a single person can control many accounts at once. My accounts here are suspicious on purpose, but I could have used, for example, names and upload random pictures for them. Automated accounts can look like normal accounts. These automated accounts are actually controlled by a bot, which is a short name for a software robot. Here, this bot was responsible for controlling Twitter accounts. But bots can do everything you can think about. Let me show you a fun little bot that can play a video game. So this game is an open source clone of Lemmings. I don't know if you remember this game, a very old video game, a very old school game. But basically in this version, you will have several penguins spawning, and you will have to lead them to the exit. But they are very stupid and can just walk straight without stopping, even if it means falling to their death. So you need to save them using different controls, like jump, build stairs, and so on. This level I want to show you is almost impossible to do as a human without having to pause the game. So I've created a bot that can do the job for me. So here the bot is taking control of the mouse and the keyboard. You can see it is now selecting action on the left side and clicking on penguins. To simplify here, the game have no idea that the player isn't a real one. There is no internal communication between the game and my bot. My bot is just faking being human. If you want to know, my script is just scanning for colors to detect penguins and then use a specific action on a specific pixel. So I implemented the list of all the actions that it needs to execute. Jump next penguin, make bridge, move the screen, make another penguin jump, etc. So we'll see that some programs are actually able to play video games, but they also perform way better. They just don't do mistakes. You can launch this script over and over again if the CPU is not overloaded with something else and your computer isn't a potato like mine, the results will be strictly identical. So bots are fun and all, but maybe you think that the ability to make a program that can play video games is useless. Well, if you think that, you are missing the point I'm trying to make. Practicing using bots with penguins is funny, but bots can do so many things. Here I want to highlight the fact that computers can also do what humans are supposed to do. This script was a very trivial example, very easy to understand, that I have created in minutes. And it already does way better than its creator, aka me. But I want you to imagine that what can happen if a lot of work and effort are put inside the bot. It might be able to do incredible things. The only limit is your imagination. So we'll talk about different kind of bots, and we'll see how they have the potential to replace us in a lot of ways. If you work all day in front of a computer, just with these examples, you can ask yourself, can I be replaced by a bot? And from a technical point of view, I personally don't see a lot of jobs that are really protected from bots. And actually the question shouldn't be if you can be replaced, but when will you be replaced? We shouldn't be scared of the future, but we need to prepare society for this transition. Programs don't have the drawbacks that humans have, but they also don't have to respect the boundaries that are defined by our reality. For computer program, matters doesn't really matter. A computer is not a real physical entity like you or your car. It can be copied an infinite amount of time, and there will be no difference between the copies and the original. So if one day a bot can replace your job, it will not only impact you, it will affect everyone with the same job. And you understand that it also have the ability to spread anywhere almost instantly. Well, now most of the amazing technology we have is used for selfies and pictures of cats, but you understand that if a piece of software like this is one day released, it will have incredible consequences. Okay, so bots can be very efficient and all, but let's be skeptical here. They are designed to accomplish a very specific task in a very specific environment. Because of that, they need to be prepared extensively to be able to do what they are supposed to do. And they can't possibly be smarter than trained humans. In the game we saw, I use my own time to give the bot a list of instructions to execute. Are we really going to do that for every single subject in every single situation? The answer is no. Computer programs can actually be designed to learn. And that leads us to our next subject, artificial intelligence. We will see together what an AI can do for us now and what it can realistically do in the near future. Funny fact, it's not actually always easy to say if a computer code is or isn't an artificial intelligence. It's a very flexible definition. But we can start by saying that an artificial intelligence should be able to change its own behavior. The AI can, for example, be a program that will start blank or without data and learn from experience. Based on this simple idea, let me show you a very simple example. So, once again, I will demonstrate this using penguins because I like penguins. So this is a platform game like Mario. And once again, I will let my script play by itself. Before launching it, I want to say that the AI here is very simple and entirely written by me and only for the purpose of this demonstration. So now we can see how amazing my AI actually is. All right. And it's dead. Okay. Okay. Let me pause this right there. So by seeing that, you might think that this is more like an artificial stupidity. And you will be correct. But similar to humans, making mistakes have nothing to do about being intelligent or stupid. For us people, mistakes can sometimes represent stupidity, but only if the same mistake is repeated over and over again by the same person. In the case of my script here, it did a mistake, but it is intelligence in a sense because it will never do this exact mistake again. So let me out of the way. All right. So it will start over, and now you can see my script is actually very, very slowly learning about this level. It won't cry, complain, or feel frustration. Just plain cold perseverance until total success. It is actually a perfect representation of the proverb, failure is a stepping stone to success. My AI here uses only timing. You can imagine it like a blind player with an incredibly good sense of rhythm, just hearing a sound when he lost. This AI could be improved in a lot of ways, but I don't want this example to be efficient. I want it to be as simple as possible so everyone can understand what is happening. And as you can see here, a simple AI can resolve a simple problem, which is here not dying. Or a more accurate description will be staying alive as long as possible. But there is a lot of ways in which you can teach an AI. learning from mistake is only one of them, but we'll talk about AI more in his dedicated section. So now let's talk about something else, computer security. Like I said before, this video is beginner friendly. So we're gonna focus on obvious things, very simple things like browsers, websites, and credentials. So when you request a website, you don't always have what you want. Here you can see a protected web page at the bottom and an obvious unprotected forgery on top. In my lectures, we'll talk in details about the URL, the S in HTTPS, which stands for secure, the presence of the padlock, and how they can protect you. In the top window here, my web browser is telling us, Firefox, my web browser, is telling us that this site is not secure. So despite the URL being facebook.com, you don't want to put your credentials in there because the connection between you and the website might be compromised. So there is a clear and obvious difference with these two. Here we have HTTPS, a padlock, and Firefox is telling us that it is perfectly secure. But do you always trust what you see? Let's forget about the fake website and and try some credentials. So that doesn't look very good, right? And when I say not good, I'm not talking about the fact that I'm not talking about my drawing here, which is obviously at least as amazing as my spelling. Here I'm talking about the fact that my password is in clear text and the page doesn't look very official anymore. This despite the fact that the web page is still apparently technically protected. You can imagine this communication like this. My local computer is the red dot in Paris and is talking to the Facebook server, the blue dot in Kiev. So now I'll connect to my VPN and try again. So here, after connecting to my VPN, the problem I had is gone. If you don't know what a VPN is, I will try to explain quickly here. Basically, I just have another computer somewhere on the internet. For example, this green dot in Greece. It means that instead of having my local computer talking directly to Facebook, I can ask my remote computer in Greece to do it for me. And this remote computer will then talk back to my local computer using an encrypted communication. You can see it as two independent connections. Basically, red doesn't know about blue, and blue doesn't know about red. So in my last demonstration, my VPN was protecting me. It means that something was probably happening on my local network. So are VPNs awesome, and should you have one? Well, VPNs are just useful when you connect from an unknown or unsecured network. We'll talk about them in details, of course, but I just want to say that they won't always be here to protect you. Let me show you that now with another very quick demonstration. So we'll reconnect to the VPN and try again. All right, so let's try. So here the problem is back. The problem is visually identical, but the problem in this demonstration is very different. In fact, the problem doesn't come from the network anymore, but from my computer itself. In this case, the VPN can't help us. But this was Firefox and Facebook. Now let's see how PayPal and Chrome can beef up your sense of security. So let's load PayPal and try up some credentials. And now you should be surprised because the URL is now very strange. But if you already know a little about IP addresses, you should recognize this as a local address. So give me a sec, I'll come back. Say sorry for that, I'm back and I brought a friend. This little thing is a Raspberry Pi. You can see it as a small $35 computer. It doesn't include a battery, so it needs to be connected to a power source, the wall, a USB port, or like me now, on an external battery. You also have smaller versions as well, like this one, called Raspberry Pi Zero, and it cost about $5. We are going to study them in details and in the section called single board computers. But why am I talking about them now? Well, this Raspberry Pi and the computer I'm using right now happens to be on the same local network. And because they are connected to the same network, they are able to easily communicate with each other using Wi-Fi radio waves. In the last example, when I tried to log in on PayPal, a communication was established between my browser and this little guy. The username and passwords are now stored in this machine. When I told you before that something strange was happening on my network, well, this one was the culprit. For my demonstrations, you can obviously see that something went wrong with a bad drawing and a dancing banana. But if you don't see anything special, it doesn't mean that nothing special is happening behind the scene. So with my lectures in computer security, I want you to understand why and where this kind of events can occur. It mainly depends on the context you are in. Is it your computer? If it is, can it be compromised? Is it your network? If it is, can it be compromised? What security features are you using? If any, can they be compromised? Etc., etc. We'll see together in details how everything works. In these specific examples, content from the web server to your web browser, with everything in between. We'll talk about languages, protocols, packets, certificates, CA, and so on. When you understand the whole picture, you can then imagine what can be altered, and we will see how. In computer security, we'll also talk in details about viruses, Trojan, ransomwares, and all sorts of different malwares. We will write some simple ones as a proof of concept and try to understand what causes an antivirus to trigger, and of course what doesn't. I told you before that fancy tools aren't always going to be able to protect you. I can give you now one reason. It isn't that simple for a tool like an antivirus to detect if something is or isn't a malware. For example, if you use an encryption software to protect your personal data, it will act as a normal program and ask you for a password to unlock your private files. But the exact same software can be used to encrypt your data against your will. And from that point, you will be considered as a victim of a ransomware because you will have to pay for this password. But as far as your computer is concerned, there is no difference. The will of the user is not an obvious concept for a computer program. So if you believe that a few security features like a firewall, an antivirus, or a VPN are going to protect you, you are mistaken. I'm not saying that these are not important. We will see together that they sometimes are. But if you don't understand exactly what they protect you from, it might give you a false sense of security that will make you vulnerable. Actually, while I'm doing this video, the security world is now struggling against Spectre and Meltdown, two security vulnerabilities that can exploit most CPU's optimization systems. So, while the rest of the world is fighting against vulnerabilities, let me share a secret with you. There is one way to protect your computers against everything. Viruses, exploits, hackers, your relatives, or whatever else. The secret is very simple. You just have to turn off your computer. A computer without power source cannot be messed with. But if you have a computer because you want to use it, it is indeed more complicated. Then we'll talk about the idea of risk assessment to determine what kind of security measures you need and what you need to know. Or in other words, know what you are not protected against. On a side note, I will also talk about how smartphones and the Internet of Things changed the global landscape of security, and how incredibly insecure some of these devices actually are. We'll divide the security subject into one for local protection, simply called computer security, and the other network security, to focus on securing communications between computers. To give you some examples, my talk about viruses, keyloggers, and antiviruses will be in the computer security section. But spoofing, man-in-the-middle attacks, and firewalls are going to be in network security. So, computer security is a legitimate subject of concern because it can be politicized and even weaponized. Cyber espionage and cyber warfare are two good examples of that. In this case, targets can be individuals, governments, and even sometimes entire countries. As of today, computer attacks against countries have always been clandestine or covert operations, and in the history of mankind, we never really had an open cyber war between countries. Nevertheless, some are already preparing themselves for this possibility. But the subject of computer security is also relevant in a time of peace, because computers are also today the base of a large amount of companies and businesses. And to maintain them up and running, they will often inject a lot of money back into their own security. In this area, we are going to talk about penetration testing in a section that will be oddly called ethical hacking, with stuff like information gathering, DDoS, zero-day exploits, privilege escalation, buffer overflows, code injections, and this kind of stuff. So all of this made computer security what it is today, a multi-billion-dollar industry. So now let's talk a little about my actual videos. Most of them aren't going to be fancy. It is just going to be me using my computer, just like I'm doing right now. You should always practice by reproducing what you will see me do. But by just watching them, you should be able to clearly understand the relationship between the computer code and its effects. So for some of you, it can end up being a lazy way to learn. Just listen to me once or twice might be enough for you. There won't be any real requirements to understand my lectures. I will really try to start from scratch and guide you from there. My goal is to teach you everything I consider useful, even if you've never used a computer before. I just don't want to lose anyone in the learning process. Most of my lectures are probably going to be unconventional because I don't like the way computer science is currently taught. For me, it's just incredibly boring, sometimes just as fun as reading a dictionary. You might be able to acquire the knowledge at the end, but you will have to suffer. I learned about computers for the fun of it, and I want everyone to have fun learning about it. If my lectures aren't entertaining, I simply failed. So I really want your honest feedback on this. And I don't like when people say that they tried to learn programming, but they didn't like it, or it was too difficult. If it is the case, I will do my best to make you think otherwise. Just give it some of your time, have fun with it, and it will become natural. I'm not saying that programming is for everyone, but everyone should give programming a try. In the future, I think programming is going to be one of the things that most people can do. Just like today, reading and writing isn't reserved for the intellectuals like it was in the past. Now almost everyone can read and write. It is not something exceptional or special. Driving is even a better example because we clearly had to adapt to the machines we use. But being able to drive a car isn't today an exceptional skill. So I think the same thing will happen in the future with programming. When talking about the new subject, I really want you to be able to use it right away. It will not be hours of theory before practice. Most of the time, we will try to see examples first, and then try to go back to see how to make it happen. Some people will very likely hate me for this, but by making computer science boring, I think we are losing a lot of potential talents right at the start. So I will sometimes oversimplify things, especially for beginners. Some will see that as a lack of objectivity, a lack of accuracy, sorry. but I don't consider all pieces of knowledge to be of equal value. So I will ignore some on purpose, and I will come back on it later if I consider when I consider that it is appropriate. All right, so for those who are interested in learning more about computers, I will start everything off by helping you creating your personalized Linux environment. I will talk about the importance of open source software, like the Linux operating system, and I will try to change the way you see and use computers. We'll talk about a basic programming, of course, mainly with these languages or type of languages. So yeah, humans and computers simply can't communicate with each other directly. Humans use words and sentences to communicate, but computers are using a two-state system from where everything is derived, called binary, a combination of zeros and ones. So if we want to talk to a computer, do we need to learn and talk in binary? Thanks to the amazing work of our predecessors, the answer is fortunately no. It is impossible for humans to handle binary efficiently. This is where a programming language comes in. It is a language that is between the binary and the English language. So humans can write something using a programming language, and the computer can convert it to binary to understand it. There's a lot of different programming languages. Some are closer to the binary and some are closer to the English language. So depending on what you want to achieve, you don't want to use the same programming language. In the section programming, I will talk in details about different types of programming languages. For all of them, we'll discuss the specialties, their qualities, or their drawbacks. We'll talk about algorithm, machine code, assembly, compilations, and stuff like that. We will also talk about all the amazing things about programming. For example, in programming, you don't need a lot of investment to do a lot. In theory, you can do everything on a 20 years old computer, or on a $5 one like this one. I'm not kidding. My current laptop, this machine, and even the small one are using the same operating system, the same synchronized content, and even the same graphical environment. So if I had a screen, I could literally use one of these as my main computer. It will be a little slower, but other than that, my system will be strictly identical. So because programming doesn't need a lot of investment, awesome projects can start and or prosper pretty much anywhere, even in a very small village in the middle of nowhere. It isn't like chemistry or biology. We don't have to wait for University X or researchers Y to actually do something about it. You just need a computer, some knowledge, time, and a bit of will. Just with that, you are in theory ready to change the world. And I think that's pretty cool. Of course, I'm here to add my grain of salt and help you learn about all of it. I will also try to help in every situations you might be in, even if they are extremes, like without internet access, without electricity, without a private computer, with very limited resources, etc. There shouldn't be anything stopping you from learning and especially contributing to our field if you really want to. I will give you all the details about that in the section dedicated to other projects. But now let's go back on programming. Sadly, some programming languages, as well as some other things, are going to be in this section called ignored. Subjects in this section are different because I will not talk about them at all. And for some of them, I will try to give you my reasons. Just to give you a handful, ASP, Swift, PowerShell, SAS, and Java. I might change my mind about some of them in the future if, for example, the reality doesn't meet with my expectations. About this list, like I said before, there will be more subjects in the future, but these are the ones I want to do first. For example, even if I enjoy and use them often, like Perl, C, or ZSH, I had to put my emotions aside and focus on more popular equivalent, respectively Python, C++, and Bash. But this is technical, so I'm not going to give you more details now, but I want you to know that there are some things that I'm not going to talk about. Okay, so now I'm going to give you some boring details about the video systems I'm going to use. Basically, I will decompose everything into 4 points: a subject, an episode, a version, and a speed. The subject will be the current subject, like JavaScript, computer security, regular expressions, and so on. Straightforward. But the number of a subject doesn't give you an order of importance. Subject 1 is not more important than subject 32. It is just a different number. The episode is a number that will often represent an objective or sometimes try to answer to a specific question. The episodes are organized by numbers that represent the evolution of the subject and often dependencies from each other. At some point, some lectures will also have the same content, but with 3 different speed. For example, if you want to learn JavaScript as your first programming language, you might be interested in the slow version instead of the normal one. In the slow version, I will give you details about everything, including very simple programming concepts like loops, conditions, variables, and so on. On the opposite end, if you already know JavaScript and you just want a quick reminder, you will be interested in the fast version. Video will also have a version because I will spend some time reading your feedbacks. I can't please everyone, but I want to make my videos as good as possible. So if I forget to talk about something or said something that might confuse some people, we will just debate about what was good and what was bad, and if needed, I will make another version for the posterity. The lectures are supposed to adapt around the viewer, whatever his previous knowledge is. For example, if you already know a little about JavaScript, you can follow the normal or fast speed lectures and go back on the slow version as soon as you don't understand what I'm talking about. By being able to switch between different speed, you will not have to waste a lot of time watching all the basics if you already know them from somewhere else or from the same lectures in the past. Depending on your situation, you will not be interested in the same things. So I will try to give you these different flavors you can juggle with. Let's take an example for a video. A lecture might be referred as SS86 E12 S2V2. Subject 86, which is Python, episode 12, speed 2, which is the normal speed, and version 2. I want every subject to be as independent as possible. This will allow me to implement a very flexible concept I talked about before, but without explaining it. The storylines. A storyline is going to use some of the videos and organize them in an order that can fit its name. For example, the storyline how to be a web developer will obviously start on HTML, and it will not contain anything about Bash. Another storyline, let's say how to be a Linux guru, will integrate Bash very early on, but won't contain anything about HTML. And storylines don't need to take everything in a subject. For some, maybe just the introduction is enough, or they can switch to another subject after episode 10 and come back afterwards for the rest. Or not. It's really up to the storyline. For example, at some point you should be able to have a personalized storyline called C++ for C programmers. So if you already know C, some C++ lectures are just going to be skipped or linked to the fast version. But as soon as the 00 programming comes in, it will obviously switch to the slow version. You can see it as a wiki, if you will. The more advanced my project is going to be, the more influence the community will have on it. So, some last words before letting you go. Like I said before, absolutely everything I do will be available for free for everyone. All the lectures, but also all the computer infrastructure I will work on. But of course, people who want to contribute in any form are welcome. Translators, website administrators, visual artists, community managers, and stuff like that. I will update all the details on my Patreon page, patreon.com/justhuman. It's actually my first try here on the crowdfunding community, and honestly, I have no idea what to expect. So I have a lot of things to talk about, but I think this video is already way too long. So if you have any questions, suggestions, or ideas, feel free to send me a message. And if you want a video with the full description of every single subject, let me know. Or you can just trust me and follow the storylines. Well, that's it for now. Congratulations if you made it to the end without skipping anything. I wish you a nice day. I'm Just Human. See you next time.